Recording. Okay, so here we have circuits. Last class, we know was the battery, right? The battery provide the potential difference for your circuit, and that's why the electron move through from the positive to the negative, the positive charges, the conventional current. The conventional current is start from positive and moving toward negative. So we always, when I put the direction of the current, that would be from positive side of the voltage battery to the negative side. Okay. So um, here to tackle these problems, we need to find the total resistance in a system. So what I do, I start with the parallel one. I see the 6 ohm and 12 ohm is parallel, right? So I can find the total resistance here because I see definitely these two are parallel. So how do we do that? When there is in a series, the rule was 1 over R1, 1 over total. It is 1 over 6 plus 1 over 12. We need to take a common denominator. So you multiply it by 2, you multiply it by 2, you get 2 over 12. Sorry, 3 over 12. You get 1 over 4. You need to flip it to find the R total here. R total here going to be 4. So I can replace this one just by 1 R like this, right? And say this is my R. Now, the total R here, maybe I just erase that. The total R here, I replaced it by just 1 R, which is 4 ohm. Now, this 4 ohm and these 2 ohms, they connected to each other. Can I ask one of you tell me, uh, is it 4 ohm and 2 ohm connected in series or in parallel? It's like 4 ohm, and here is 2 ohm, right? Are they series or parallel? The total is 4 ohm, right? Okay, they are in series because they are back to back. If they are two ends of these two attaching to each other, like this end attached to that, this end to attach to that without any interruption, we say this is parallel. So this is parallel. But if they are back to back, they are in series. Now what I'm gonna do, I'm taking this 4 ohm and 2 ohm. So you know two resistance in series, you add them up. So our total here, it is 4 plus 2, which is 6. Okay. Now we're moving to the next one. Now I just have everything here replace. Everything here is replaced by what? By 6 ohm. Now I need to try to see 6 ohm and this 3 ohm here. Are they in parallel or are they in series form connecting to each other? Can anyone tell me? This 6 ohm and 3 ohm. The whole thing's here connected to the 3 ohm, right? I want to see if this is a parallel connection or series connection. Anyone can tell me?
Would it be parallel?
Very good. Parallel. Can you tell me why?
Because they're not taking one path and the current is splitting in two.
Yeah, because the two end of them connecting to each other, like this end to this end and this end to this end, right? They are not back to back. The two ends cross them is connected to the two ends here. True. When they are like this, the two end of R1 is connected to the two end of the R2 without any interruption, right? So these are parallel, make sure. The whole thing here is connected to 3 ohm parallel. I'm going to use the different color, maybe show that better. Now 3 ohm and this, taking the whole things here, right? Saying that R total is 1 over R total is equal to 1 over 3 plus 1 over 6. Common denominator is going to be 3 over 6, going to be 1 over 2. So R total over there going to be what? R total. R total will be 2. Okay? So this is for that. Now I'm going to take the whole things here, which is 2, 1, and 4. So instead of that whole things here, I just put 2, and it's going to be my circuit now. I have that 1 ohm. I have, instead of that, I replace it by what? 2 ohm here that I just calculated. And here is 4 ohm, right? So I simply add them up because they are in series. See, they are connected back to back. So here I'm gonna use the different color. So our total here will be 1 plus 2 plus 4 because they are back to back. 7 ohm, right? Now I got all our total of system because I got through everything and that would be my final R total of the system. Now why I do this? Because I need to find the current. This battery supply a current. I need to find this current here. So maybe I just put the things here for you. First we did this. These two was in parallel. Then the whole thing's parallel. That was series. It was here too. And then these two parallel. Here is 3. And then all of that in series. It's 4. Give me the R system total. Now the fifth step is to find this I here. You know that the V is equal to what? Ri. You can rearrange for I is voltage divided by R. The voltage here that the battery provides is 8 divided by the R. The total R is 7. And I need my calculator. Save that. Save that. Uh, if I give you these questions, you just do the 2 decimal places is enough when you're calculating this. Or just keep it as 8 over 7. 8 over 7, so it's going to be 1.14. So the I that passed through 1 ohm is 1.14. When it comes here, it will split up. It become, I call it I1, and I call this one I2. When it become here, again, it's split up here and here. We call it I3, and here is, we call it I4. Now, here is still I, right? Here, this is still I, and here is still I. So the current passing through 4 ohm is going to be what? 1.14. The current passing through 1 ohm is 1.14. Now my job is to find what? The current passing through this. Okay. Now, uh, let's let's just erase this. Okay. Can anyone tell me what is the potential difference? What is the potential difference across 1 ohm? How do I find it? Can I find the potential difference across 1 ohm? Yes, to find the voltage, you need the current and resistance. See, we have a current and a resistance for 1 ohm, right? So the voltage is simply is equal to Ri. Here, R multiplied by I, right? So V is equal to just 1.14, oops, multiplied by 1, which is 1.14. Let me just make it clear. 1.14 volts. The same thing I can do it for this. The voltage is 1.14 multiplied by 4. 4.57. Okay? So I get the voltage across 1 ohm. I get the voltage across 4 ohm. Can anyone tell me how do I find the voltage across the whole things here? Any suggestion? I want to find a voltage across that. I know the voltage of the battery is 8 volts, right? And here is 1 ohm. I don't know what is the voltage across these 2 points. I know the voltage across 4 is 4.57. Any suggestion? Okay, they are back to back, right? 1 ohm connected in a series with the whole things here and connect this one connected in series with 4 ohm. They are connected in series. When the voltage connected in series, what was the rule? When you add them up, they are equal to the voltage of the battery. Do you remember the rules? V1 plus V2 plus V3 is equal to the V total that the battery provides. So actually, if this is fifth, this is going to be 6. It's going to be 6. It's going to be 7. Step 8. V total battery is equal to VR1 plus VR, I guess, total here that you see, plus VR4. I call it 4, okay? So V total here is 8. R1 is 1. I don't know what is that across that. Or total, I call it. VR4 is 4. Then the VR total here is going to be 3, right? So 8 minus 5 is 3. Okay? So I know the V across the whole things is 3. Means the voltage across the 3 ohm is what? 3 ohms gonna be 3 because this 2 point here, if you get it, it could be connected to that without any change, true? So I got that. That was my step 8, coming from step 8. And step 9, I have resistance, I have current, I can quickly multiply these two. E is equal to Ri. So it's 3 multiplied by 3. That's 9. So I got a voltage across that. I multiply the voltage by R, get I. So I have that. Now, if the voltage across the 3 ohm and the whole things, because they are in parallel, right, is equal to 3, the voltage across these whole things would be 3 too, right? Because this is connected to this in parallel. So the voltage across this is going to be 3. Okay.
Miss, I have a
Yes.
question. For your step number 8, you calculated the voltage RT is equal to 3. So why did you put it under like current?
Oh, did I do that? Okay, sorry. Hmm. Okay, thank you, thank you. Okay, so I'll just go back. That was my mistake. Okay, sorry. That was a voltage, right? Now we know the current is what? I is equal to V over R. We do have V, which is 3 over 3, which your R is. So it's going to be 1. Okay, thanks for correcting me. Just so the I have I passing through what? 3 ohm. Means I have this one. I have this one to be 1. So if this incoming I that I get is 1.14, and here is the I current is 1, what would be the other I? Because the incoming is equal to addition of the outgoing, right? What would be I1? Anyone can tell me? What would be the I1? So the I here, I'm gonna just put that as step 9. Okay, 9 actually, this would be my 8. Here it's gonna be 9. Now step 10 tells you that I is equal to I1 plus I2. Why is that? Because incoming will divide it to 2 branches. So incoming should be equal to addition of the outgoing because it's like a river coming, some of that going this way, some of that going this way, but addition of these two is equal to the actual current came, right? So here is 1.14. I1 I don't have, but I have I2 to be 1. So I1 would be 0.14. So 0.14 is here. Come here again, become 2 branches. Again, these 2 branches come together and pass through 2, right? Means this will be the same as I2. Sorry, this is the same as I1 because I1 coming, branch, and then come together again, become I1, right? So that would be I1. So the current passing through 2 ohm, just here, gonna be the same as I1, and I1 was what? 0.14. So this is 0.14. So from that, easily I can calculate the V. V again is equal to Ri2 multiplied by 0.14 is 0.28. Okay. Okay, so this is really like puzzle, right? Now going back here, we need to find the i's here. To find the i's here, first, I have a R total here. You remember that? What was it? Because these two were in parallel, I said R total here is 4. The R total in this one, I mean. We got the R total here to be 4. Okay? And I know the current coming is I, right? So I can find the voltage here. Voltage is Ri. The R is 4. I is what? 0.14. Okay, 0.14. 0.56.
Miss.
Yes.
So I was like checking with some of the answers on like the same question on the Google Classroom, and
Mm-hmm.
it's saying that instead of 3 for like the voltage for resistor 2, it's 2.3, and like the current for resistor 2 is also different. So like I'm a little bit confused why the answers are different.
Sorry, which you said the voltage here is
No,
different
the basically the row for resistor 2 is different.
for the resistor 2, the R. Okay, what is the current then over there? Just want to check.
For which box?
2.
Oh, when I say 2, like I mean like the row for resistor 2, like where you have step.
Oh, okay, so this resistors. Okay.
Yes.
So you have this one different than what it is.
Yeah, from like the answers on the Google Classroom.
Okay, how about the rest of that the same? I just want to find if I did a mistake here. I can go back and check.
6 was also different, like the row for resistor 6.
Okay. How about the first row? It was okay?
Yeah, the first row is fine.
Okay. I'm gonna go and check back, but if this is so, so the first row is okay. You said the second row. Definitely I can check that voltage. Okay. So I'm gonna check the voltage, okay? Here the voltage across this one is Ri, right? Um, which we did. This multiplied by that is this. The voltage across 4 is gonna be Ri. I is 1.14. Maybe I just check these values, but I don't think so. It's different, but I'll just check that. Okay.
Yes,
Yes?
I just joined.
Who's that?
Sevde.
Okay, thank you. Mm, okay, I see my mistakes. I think instead of the V here, see that? I put the resistance. I'm gonna check that back. So it's a VR1. V was 1.14, okay? I put it 1. And VR4, VR4, right? VR4 here. It's 4.57. I should change this to, okay? Oops. Might be too tired. Mm. Okay, I'm gonna be put that this one, 1.14. And this one, the VV got here, 4.57. I'm gonna calculate this. UV 8 minus 1.14 minus 4.57. Okay, it's gonna be 2.29. Okay, I'm gonna change that one because that was the voltage here. 2.29. The voltage across the whole things here is the same as the voltage across it because it's kind of connected to this 2 point without interruption. And I need to change that. Two point 29 over what? Maybe I just check that one more time. So I'm trying to find I, which is V over R. R is 3. That's divided by 3 is 0.76. Okay, right? That's now correcting things. Then I have to check everything back. This one we are fine, but the current that I got here um, into, and I used that there, right? 1.14 is fine. I1 plus I2. How do I get I2?
Miss,
Yes, who's that?
Stephanie,
Mm-hmm.
are you able to explain your step 8 again?
8. Step 8.
Yeah.
Okay. So look at this battery is providing the voltage, right? So across the battery, there is a voltage, and this voltage provide the power. So the voltage across the battery equivalent to the addition of all of the voltage that you see here. Since they are connected in series, so the voltage across the 1 ohm, the whole thing's here, plus the voltage here, because these three are connected in parallel. Which when I said 3, is the 1 ohm and the whole system here, crazy system here, and that, right? They are connected in series. So VR1 and VR total here plus VR4, that's equivalent to the voltage of the battery. That was the rule. V of the battery, if they are in series, addition of all of the voltage equal to the V of the battery, which we have V of R1. And how do I know V of R1? Just I got a current, I got a resistance, you got a V, which is 1.14. And again, V and R multiply to each other for the third one, right? You got V here. So knowing all of the V except the V across this crazy system, we find the V across that, right? Because this is the only unknown. Rearrange to get that. So we get the voltage across the whole things means it's the same as the voltage across 3. Why? Because the tree is connected to the whole as a parallel. See these two ends here and these two ends get connected to each other without any interruptions. Okay. I'm trying to find the I1 and I2. I can't find I2. See, this is I2, uh, which is 0.76. So I have to correct myself here. Turn it to 0.76. And then I need to calculate for I1. The reason is that the I coming is split to the I. So I coming is the same as I1 plus I2. So 1.14 minus plus 0.76. 0.38. So this I here is 0.38. I'm gonna change that there because I was wrong kind of. The I passing through through I2, we got it, right? Now I'm gonna find the I passing the whole I here, right? I call it I1. 0.38. Also said that this I1 coming is the same as the I1 passing through the 2 ohm, right? Whereas the 2 ohm is here. So I put that 0.38. This is coming from step 10. Now I can't find the voltage across these 2 ohm, right? By just saying that V is equal to Ri, R is 2, I is 0.38. 0.76. Okay. Now I got the V here. I know it because these total V here, I want to really erase, but the V across the whole things on the top here is the same as the V across 3 ohm. And the reason is that they are connected in parallel. So the whole V here is equal to what? It's equal to the V across the 3 ohm. And that V was 2.29, remember? Just gonna remind you, if I had a voltmeter here, this voltmeter would be equal to what? 2.29, right? So the V here is the same as the whole V here. If I know the V across this, which is V here is 0.76, and I know the V across the whole things here is 2.29, I can find that here, right? So step I want to make that a step. So step 11, V across R3, okay, which is, maybe I just go with these numbers here, right? Across 3 ohm is R2. V across R2 is the same as V across 2 ohm is R6 plus R. I want to make a note for you. I cannot, I guess. Okay, again. The whole thing's here. V across R2 is the same as the V across everything that you see here, which is equal to V across R6 plus V across a parallel system that you see there. Put it like that. V across R2 is 0.70, 2.29. It's 2.29. V cross R6, we got it to be 0.76. I want to find a V across the parallel system. 2.29, 1.53. Now I get a V across the whole things. Let me see if I can sub anything there for 6 ohm and 12 ohm. Yeah, I cannot substitute unless I get the V here, right? Yeah, I got a V across these parallel things, which is 1.53. Put that there. It came from the step 11. Now simply I can use the I is equal to V over R to find the I, right? One point 53 divided by 6, 0.255. And so divided by 12 is 0.1275. Okay. Right. Now the current, of course, the battery will provide is the same as I. I need to write it down. And you know that I here that we got, it was what? It's passing through the 4 ohm, which is 1.14. Okay. And the resistance, the total resistance that we got from the step, which is the we got a total resistance. I got it our total of the system. This is 1, this is 2, this is 3. Here's the step 4. Okay, that was my system, which is 7. That was from step 4. And that was from step 5, I guess. Where's the step 5? Yeah, here. That was from step 5. Okay, I know a hard question, but do you have any question? Maybe I just give you a simpler one.
Yes, I just wanted to let you know that I joined late.
Who's that?
This Henny.
Okay, give me a second. I need to stop this.